So here we go, 1.6c, and I'm on page 71, and we're doing factoring other trinomials by trial and error like we ended 1.6b with a few minutes ago. So I'm looking at example 7, and there is the problem right there. One of the things I want to focus on before we get started too much is this y and this y squared. Okay. What I normally suggest as we do this, just like when we were factoring before and we had an x squared, let's just say, for example, x squared minus 8x plus 6. We had two binomials. Put an x there and an x there because of the x squared. The same is going to be true with the y. We're going to put a y here and a y here. So then what we're looking for are the numbers. So if you are given a variable as your third term, just put it in here at the end. So we know we're going to get an x and an x, and we're going to have a y and a y, because when we multiply first terms in FOIL, we're going to get an x squared. Last terms in FOIL, we're going to get a y squared. So you can just realize you're going to have an x first and a y second there. So all that to say, we'll leave that there, and we will continue on with trying to find out what we're missing there, what numbers we're looking at. One of the things to look at, we have a plus sign here and a plus sign here. We know because of that we're going to have a plus and a plus. So now what we're going to do, from last video that I told you, we take the first coefficient, the leading coefficient, and the last coefficient. And, whoops, that is not a 5, that is a 15, isn't it? And we multiply them, and we get 30. Now we write down the factors. 3, 10, 2, 15, 5, 6, 30, 1. Are there any more? Since we don't have any positives or negatives, since this is a positive 30, we're just finding two positive numbers multiplied together that give me 30, added together give me 13. So if you remember right, what we did is we rewrote that top equation, and instead of the 13xy, we're going to write 3x plus 10 xy, whoops, this should have a y there too, because that, when you add those two together, you get this 13xy. So we put the xy in there so that we would add those together and get the 13xy, and we have the 15y squared. So next step is to group. So let's go ahead and do that by putting a parenthesis around these first two, and a parenthesis around these two. We're going to look here and see if there's anything we can factor out. There is an x we can factor out, and we're left with 2x plus 3y. And then over here, we can factor out a 5y, and we're left with 2x plus 3y. And notice, again, what is in the parentheses has to be the same in both of these sets here. So now all we do is put the x, what's outside the parentheses, together, and what's inside the parentheses together. And at that point, we're done. So notice we have the y here and the y here, because when we do the last terms, when we're doing FOIL, 5y times 3y is our 15y squared. Our x plus 2x is our 2x squared. And then when we do the inside, we get 10xy, outside 3xy, which are these two here. Add those together, and we're back to our 13xy. So the one I have here is on page 72, top of the page, example number 8. So according to the rule, or the suggestion that I gave, we take this term times this term. That's going to be an awful big number. So rather than do that, I'm going to look and see if there's some things I can factor out of here before I get started with actually the full-on factoring the trinomial. So one thing that I do know is that my smallest number is a 3. So I look and say, does 3 go into 18 and 36? If it does, I'm going to pull it out. And it does. And that gives me a 6. It gives me a 1. And gives me a 12. So now I'm going to look at my letters, my variables, see if there's anything that I can pull out. So remember, I look for the x variable that has the smallest exponent, which is this one. So that means that I can pull 1 out of there and leaves me a few in other than that. So I pull 1 out, and this changes to a 2 because I took 1 out. This changes to a 1, or an x to the first power, because I took 1 out, and this will be gone. So there's no x. Now let's look at the y's. I've got 1 here, 2 here, and 3 here. So because my smallest exponent is a 1, I can only pull 1 out, which means there are none over here. I took 1 here, so I have 1 left. I took 1 here, so I have 2 left. So this is the trinomial that I'm going to use in order to solve this. So what happens is this 3xy just gets drug along with it for the ride. Okay, so let's take the 6 times negative 12, so we get negative 72. All right, so we're going to have a whole bunch of numbers with that 72 there to factor. So we have 72 in 1, and because it's negative, this could be negative or this. So, I mean, there's a list a mile long. So one of the things that kind of gives you a little bit of an idea of which numbers to pick. We need them to multiply together and give me negative 72, add together and give me a 1. So that means the difference between the two numbers I pick has to be 1, so that when I add them, I get a 1. So if I had a 36 and 2, that wouldn't work. If I had an 18 and a 4, that's looking better. If I had a 9 and an 8, there is 1 between them. So which one is it? Is it negative 9, positive 8, or positive 9, negative 8? Well, when I add them, I want a positive 1 here. So therefore, this is the one that I have to get where the larger number is positive. So I'm just going to write my 3xy. 6x squared plus, oh, nope. If you remember right, I said if you have a negative and a positive, always put the negative first. Okay. Now we're going to group. Group these two, and we're going to group these two. So I still have my 3xy, and I'm going to make a brace here because I'm going to pull something out of here. Let's see, I can pull out a 2 and an x, and I'm left with a 3x minus 4y. Now I'm going to pull out a 3 here, because a 3 is common to the 9 and 12. And I'm also going to pull out a y, because a y is common to here and here. And that's going to leave me with a 3x minus 4y. Okay, notice again, what I have in parentheses here is the same as what I have here. It has to be that way. So now I have 3xy, and I'm going to put these two together. And I'm going to put this down. And at that point, I'm done. And if you don't think it gets hard enough, we just keep going. Let's look at example 9. 12x to the fourth plus 17x squared plus 6. All right. So there is nothing common to any of those three terms. One of the problems is 17 is a prime number, so there are no factors. I have an x to the fourth here, an x squared here, but I don't have an x there, so I can't pull an x out there. So I'm kind of stuck with what I've got. So what I need to do is, first of all, recognize that this and this can be written differently than what they are. Well, no, let's just leave that alone. But let's look at the x to the fourth. X to the fourth can be written as x squared squared, right? Because 2 times 2 is 4. If that's the case, I could rewrite this equation as 12x squared squared like that. So that means when I make my two binomials, I'm going to have an x squared here and an x squared here. So that when I multiply the first terms in FOIL, x squared times x squared, I'm going to get an x to the fourth back. So whenever you're asked to factor and the exponent is an even number, make sure you write it with the 2 is the furthest out exponent, and whatever number you multiply 2 by to get it to be the number. So for instance, if I had x to the sixth, I would write it as x, and I'd put a 2 up there, and I'd put a 3 on that exponent here because 3 times 2 is 6. Whatever times 2 is going to give you this, that's the number that you put in here. And then that's the number that goes here and over here, so that when you multiply them, you get your exponent back. Okay, I know that's really, really confusing, but let's just keep going and see if after some practice you can get this. All right, so we have a 12 and we have a 6, so we have a 72. So we want factors of 72 such that when we add them together, we get 17. So I know 72 and 1 won't work because, you either get 72 plus 1 or 72 minus 1. So that won't work. And 36 and 2 doesn't work. 9 and 4 doesn't work. 8 and 9 do work. 8 times 9 is 72. 8 plus 9 is 17. So let's go ahead and write this whole thing using the 8 and 9. 12 x squared, and I'm going to leave that in parentheses, plus 8x plus squared 9x squared plus 6. All right, notice that I have x squared there and x squared there because when I add these together, remember when you add exponents, you only add the coefficient, the number in front of the exponent. So when I add these, I'm going to get 17x squared. So I have to write it so that I can get that. All right, so let's go ahead and put this in parentheses and this in parentheses and see what we get. So we can factor out a 4. And here we're left with a 3. And here we're left with a 2, and we've got a plus sign. Okay, now the variable. We have an x squared. We have 2 x squareds there and 1 x squared there. So we're going to take one of those out, and we're left with 1 in here because we had 2 here. We don't have any more there, so that's why we're leaving it the way it is. Got a 9x squared plus 6. I can pull out a 3. And that's it there. Whoops. And I've got a 3x left here and a plus 2 here. Whoops, 3x squared. because of this squared. So again, this is the same as this, and that's what has to be the case. So now let's write my 4x squared together plus 3, and then my 3x squared plus 2. Okay, example 10. Last one before we get into perfect square trinomials and then the difference of two squares. Oh my goodness, this lesson goes on and on and on. May have 42 videos by the time we're done with it. All right, so example 10, 2x squared, x minus 3 minus 5x. All right, so one of the things you need to know is, or look at and say, do I have things that are common? 2, 5, and 3, nothing goes evenly into those, so I can't pull anything out of there. X squared, an x, and I don't have any x's here. But I do have an x minus 3 common to all three of them, so that's what I'm going to end up factoring out. And what do I have left? 2x squared minus 5x minus 3. Because I factored the x minus 3 out. So all that's left is this, this, and this. All right, so now I can let this just tag along. It's always going to be there. Not going to change at all. It's just going to follow me. I'm going to take my 2 times negative 3 and get negative 6. Two numbers added together give me negative 5. So I've got negative 3 and 2. 3, negative 2, 6, negative 1, negative 6, or 1. So all of those numbers will add together and give me a negative 5. So not all of them add together, but we do have 3 and 2 is 5, 3 and 2 is 5, 6 minus 1 is 5, 6 minus 1 is 5. But you have to look and see what's going on here. We are adding them together, getting negative 5. So the largest one gives me the sign. So it has to be that one. So I'm going to rewrite this again. Okay, then I'm going to group. And now I've got x minus 3 because that just follows us. Can I factor anything out of there? Yes, I can factor a 2x out of there. And I'm left with x minus 3. Can I factor anything out of here? No. So I'm left with x minus 3. Notice this and this are the same. They have to be. We've said that over and over. Now, even though we can't factor anything out of here, there is an assumed 1 there. So that way, when we have x minus 3, and then we write what's on the outside, and then what we have common, we still get an answer that makes sense. So the other thing you can do, that's the answer. You could put these two together. The book did. Because there's two of them, they put a squared there. And we're good to go. So that ends up being what we want for an answer. That's also fine. All right, let's go to 1.6 D as in Delta for the next video.